guys remember that we're writing a test on Thursday, no?
Yes.
Trigonometry and analytical. Okay, let's start marking. So at the first one, they asked you to calculate the gradient of AC, which was straightforward. You had both of the coordinates. It was just substitution into the formula, and then you get 3 over 4. Did you get that? Why not? Do you have 11 minus 3, 10 minus negative 2? 11 minus 3, oh, that's 8. Oi, sorry. Then it's 2 over 3. Now I'm going to have to redo it. Okay, so 3.1, the gradient of AC was y minus y over x minus x. It's 11 minus 3 over 10 minus negative 2. That gives 8 over 12, and that is 2 over 3. Is that better?
Yes.
Okay. Right, 3.2. Determine the equation of line DE in the form y equal to mx plus c. Now, I want you to see that with the information you have at DE, it is not possible for us to calculate the gradient of DE. So I told you there are two ways of calculating, either with two coordinates or when you've got the inclination angle. You don't have either of that. So if you don't have that, you have to steal. When we steal, we're looking for a parallel line or perpendicular line. But you all see the parallel lines there. So I just steal ACs. Okay, so the gradient of AC is equal to the gradient of DE because AC is parallel to DE. Then I know it's y equal to 2 over 3x plus c. Now to find the equation, I just need one coordinate to substitute into the place of x and y, and then I can calculate the unknown value of c. So the coordinate I have there is d. It's 5 and negative 1. So I put it in there, negative 1 equal to 2 over 3 times 5 plus c. And then c is going to be equal to is it negative 17 over 15? Did you get that? Right, sorry. Negative 13 over 3. So the equation is going to be 2 over 3x minus 13 over 3. Then they asked you to calculate the size of alpha. So it's that one there. We spoke about this last week. I told you that it's the inclination angle there plus 90 degrees. Because the inclination angle is an angle with any horizontal line. We just usually use the x-axis, but it can be any horizontal line. So I know that at 3.3, the tan of alpha 1, I broke it into two pieces, né? Is going to be equal to 2 over 3, because that's the gradient of AC. And then you type shift tan 2 over 3, and you get an answer of 33,69. Do you all agree with that? Right, alpha 2 is equal to 90 degrees. Thus, alpha is going to be equal to 123,69 degrees. Do you understand that? Then they say at 3.4, B is a point in the first quadrant such that A, B, D, E in that order forms a rectangle. So I spoke to you about this last week. We said that they are going to ask questions of B, E, but you don't have the coordinates of either B or E. But because it's a rectangle, you need to realize that AD will be the same length and they will have the same midpoint. Okay, do you all understand that? Right, so at 3.4.1 they asked for the coordinates of M, the midpoint of B. We are not going to calculate the midpoint of BE. We are going to calculate the midpoint of AD. And then we're going to say it's 5 plus negative 2 divided by 2. And negative 1 plus 3 divided by 2. And then my answer will be 3 over 2 and 1. Alright, now you have to say why you are able to steal this. Okay, so you can say the midpoint of AD is equal to the midpoint of BE, but give your reason. So you just say rectangle diagonals bisect. So you have to say why you are doing this. You have to give a reason. Okay, it counts them all. They say that it is a rectangle, but because it is a rectangle, you know the diagonals bisect. If it was just a quadrilateral, they didn't specify that it's a parallelogram or whatever, you couldn't use that property. But because they are saying it is a rectangle, you can just say the diagonals bisect. Are you asking whether you must say rectangle? It's okay. They already said it's a rectangle. Okay, 3.4.2, you had to calculate the length of the diagonal BE. Once again, you can't calculate it. But because of the rectangle, we know that the diagonals are equal. Remember, this is not the case for a normal parallelogram. At a parallelogram, the diagonals aren't equal. They do bisect each other, but they're not equal. A square's diagonals are equal, and a rectangle's diagonals are equal. All right, so I can say that BE, it doesn't matter at what stage you say this, BE is equal to AD, because it's a rectangle, the diagonals are equal. And therefore you can just calculate the length of AD. Then you're going to say minus 2 minus 5 squared plus 3 minus negative 1 squared. And then you get an answer of, is it root 65? Yes. And that is the length of BE as well. How did it go with this question? Good. Okay. The last question, question 4, was a little bit tough. Okay, it was a tougher question. But if you are okay with number 3, then I'm happy. That's the normal trend of the questions that we're going to work out, or that we're going to get in a test. Okay, question 4. I did explain this to you, but I'm going to show you once again. This is hard to understand. But I also showed you guys that the only thing I'm doing is what I would have done if there were numbers. I didn't use a different method. I didn't have to reinvent analytical geometry. I just did the normal things. So the normal things that we do is when we get an equation and it's not in standard form, then we try to get it into standard form. So when I take that equation, SP is equal to x plus ay minus a. I just want to say this quickly. So you get to a point where you don't know what to do. You don't know that this will be the correct thing to do. But at this stage, it's the only thing you can do. Does that make sense to you? Then just start wherever you can do something. Just start there. Okay, so I take that equation. I take over the x, it becomes minus x, and the a becomes plus a. Then I divide each term with a. So there the a disappears, there it's negative x over a, and there I've got a over a. And now I know a over a is 1. Although I don't know what a is. Whatever a is going to be, it's going to be the same numerator and the same denominator. Therefore, I know that value is 1. Now we need to have the knowledge that that c value is also the y-intercept of the straight line. Now, if you look at the straight line SP, the y-intercept will be right here. And that means that that value is 1. Do you all understand that? Do you see I didn't do anything funny? I just got the equation into standard form, and that was literally the only thing I could do. There was nothing else that I could do. So therefore I know P is going to be 0 and 1. Next, I asked you to find or to calculate the value of A. Now, I have that equation. I had it here, no? That's what I had from the previous question. Now, all I need is another coordinate. Now, the reason I don't use that coordinate, if I have this, if I put the 0 in there, in the place of x, the a value will disappear because 0 divided by anything will be 0. So I won't be able to calculate a. That's why I looked for a different coordinate. Now they also gave me one other piece of information, and that's that OS is 3 times OP. Now what's the length of OP? That length. It's 1 because that value is 1. So this one is 3 times what that one is. I know it's sometimes difficult to read this. We think that this one is 3 times the length of that one. Did you also struggle with that or not? Okay, remember, OS is 3 times whatever OP is. So OP is 1, therefore OS will be 3 times 1, which is 3. Do you understand that? And that gives me this coordinate of 3 and 0. Because that's the x value, 1, 2, 3. And it's on the x-axis, so I know the y is 0. So now I have a coordinate, 3 and 0, that I can use to calculate the value of a. Do you understand that? Are you sure? Okay, so I substitute the 3 in there and the 0 there. Then I take the 1 over its minus 1. And now do you remember when your variable is in the denominator, you just swap it with the numerator. Do you remember that? This is the numerator, you just swap it with the answer, sorry. So this one and this one, they just swap around, and then a is equal to 3. Because it's negative 3 divided by negative 1, that gives you an answer of 3. Once again, although it's a hard question, I didn't do anything funny. I used the same method we've been using all the time. Nothing new. Next, I asked you to calculate the equation of RT in the form y equal to mx plus c if it is given that r is equal to 3. Okay, let me just show you my plan. Maybe you used a different plan. So RT, it's this one. If I were to calculate the gradient, I need 2 coordinates. But I don't have 2 coordinates, I only have 1. I don't have an inclination angle, so I can't calculate it. If I can't calculate it, I need to see if I can steal it. So I see there is a perpendicular line. Those two are perpendicular. Can I calculate the gradient of PS? Because I have both of the coordinates. And once I have that gradient, I can swap it around with a negative. Then I've got the gradient of RT. Do you understand my plan? When I've got the gradient, I also have a coordinate that I can substitute to calculate C. Okay, so I calculated the gradient of PS. It gave me negative a third. Now I say because PS is perpendicular to RT, I just swap it around with a negative, so I know the gradient of RT is 3. Now, if you were wakker, you might have seen that that is the y-intercept. Do you see it's the y-intercept of the line? That means this is C. Do you all see it? But maybe you didn't see it, then you would use the coordinate, substitute in there, and then you also find C to be negative 5 and 2 over 3. And then you have your equation. 3x minus 5 and 2 over 3. Nonkeba, I see you are not writing. Did you get it right? I'm glad. Who else got it right? Let me see. Well done. Well done. Okay, you are doing very good. Next, we had to calculate the coordinates of R, the point where PS and TR meet. So there's PS, there's TR. How do we calculate the point of intersection? We let the two equations be equal to each other. Okay, so the two equations that I have was negative a third x plus 1 and 3x minus 5 and 2 over 3. So I just let them be equal to each other. Do you like the denominators? No, so I just multiplied each term with 3. That one became minus 1, that one became 3, that one became 9, that one became minus 17. Just shuffled them and then I found x to be 2. Once you have x, you can substitute into either of the equations and then you find y to be a third. Okay, the next question was to calculate the area of PRT. So do you see that PRT is a right angle triangle? Which means that this is your base and this is your perpendicular height. Or other way around, doesn't make a difference. So what I did is they gave me R's coordinate now in any case, but I already calculated it. So I calculated the length of RT and I calculated the length of PR. And then I said a half times the one times the other. Is that the same method that you guys used? Is there someone that used a different method? Anything else? Not. Okay. So I said PR is 2 minus 0 squared and the third minus 1 squared, and I found it to be 2 root 10 over 3. Leakwe, did you get it the same answer there? I just want someone to check up on the answers. You've got it right. Same answer. TR Once again, distance formula, I get 2 root 10. Kumo, you got the same. Now I can't check up. Why did you have the same substitution? Okay. Alright, and now it's a half times base times perpendicular height. It's a half times 2 root 10 over 3 times 2 root 10. Then you get 20 over 3. And then you can also add the units squared. Okay, calculate giving reasons the radius of a circle passing through the points P, R, and T. So this is similar to the other one that we had the other day, ne? Okay, there's a right angle, so we know this is an angle in a semicircle, ne? That means PT is the diameter. Okay. No, I used the wrong line now. Okay, so we need to get the length of PT. What is the length of PT? If it's 1 there, and it goes down to negative 5 and 2 over 3, that means it's 6 and 2 over 3. Do you agree with that? So all I'm going to do is divide it by 2. So it's 20 over 3 divided by 2, and that gives me 10 over 3. That's the radius, and the reason is the converse of angle in semicircle. Okay, I just quickly want to go and print something for you. You can quickly go through this. Please don't talk and play around, don't waste your time. Okay, I have copied for you the 2020 Eastern Cape November exam. So you can see this is the way that it's asked in the exam. So you're not going to be surprised with something different. It's all November question papers. So what you're going to do for me now is question 1 and question 2. You will see it's very, very easy actually. Do you need one? Did you send the papers to the back? Oh my word. Okay. So you're going to do this for me. Only question 1 and question 2 for tomorrow. Then tomorrow during class, we are going to do the trigonometry of question 3 and question 4. Just to recap that a bit for the test on Thursday. Okay. So you can start now.